New one. One minute. Hello everyone, welcome to my channel. So today we are going to do Leetcode bi-weekly challenge second question, which is medium level question. So minimum operation to make array equal to. So let us first read this question, then about constraint, then example and the final coding part for the same. So here in this question, you are given two integer arrays nums1, nums2 of equal length n and an integer k. You can perform the following operation on nums1. So whatever operations are there, we are required to perform on nums1, but we are required to compare them with nums2. So here the operations are, we are required to choose two indices I and j, and we are required to increment nums1 of I by k and decrement nums1j by k. In other words, nums1 I equals to nums1I plus k and nums1j equals to nums1j minus k. And nums1 is said to be equal to nums2 if for all the indices of I such that I remains between the 0 and n, nums1 of I equals to nums2 of I. And we are required to return the minimum number of operations required to make nums1 equal to nums2. If it is impossible to make them equal, then we are required to return -1. So basically, we are here required to compare both of the nums1 and nums2 and required to check all those elements which are there on which we are required to perform these operation by choosing I and j index, and the operation should be like that. If we are choosing this particular index, in this first example, if we can see, here we are choosing I equals to 2 and j equal to 0, right? So I equals to 2, I is this one and j is this one. So as per the rule which is given in the question, so I would be that index where we are incrementing by k. So basically we will be increment by k and here we will be decrement by k. So the new array that will become would be something like this. And then again we will be choosing another set of I and j until and unless we will be having nums1 equals to nums2. Till then we will be choosing I and j, and when it becomes equal to nums2, then surely we are required to return that how many number of pairs we were required to choose, and thus that simply indicates that how many number of operations we have done so far, and that is what we are required to return. And we are required to return with the minimum number of operations which can be done. So basically, this question is like, because here we are required to repetitively add up, right, and repetitively subtract, means side by side we are required to add also and subtract also, right? So as per that only, we will be going ahead and checking that for each element which is there, if it is less than the nums2 element at that index, then we will be performing operations accordingly. And if it is greater than uh, that nums2, then again we will be performing our operation accordingly. Means basically, see here in the I plus k, right, and j minus k. So basically here 1 plus 3, then again 3. That will be making it equals to 7 as per this nums2, right? So here we are adding 3 two times so that we are able to get that 7. So basically here if we can here we can see that if we basically multiply with some other variable, means if we basically multiply this k with some other x, right? So we are able to get a 7. So we are required to figure out with this x only for going ahead to get our nums2. This is one part of this particular question. And the second part of this particular question is that we are required to check that are there all possible operations in such manner, means if this I which we are calculating means which we are taking here, if this particular I which is there, if we add up, means basically here all the operations which we are doing means I and j, if here we can see that 4 and 1, that 4 minus 1 equals to 3 means and to be precise here 4 is basically greater than 1, right? So in this particular scenario, what we can do to make it equal to 1 would be simply subtracting by basically k, so that it could become equal to 1, right? And how many times we are required to subtract k from this 4 to get the 1, that we are required to calculate here also, right? And then this 3 and 3 are already equal, and then 1 and 7, here 1 is basically less than 7. So here we are required to add x times k into this particular one so that it becomes equal to 7. So basically, the thing is that we are required to also keep account that number of operations which are being done on I and number of operations which are being done on jth index, all together they should also be equal. So in that context also we are required to keep a check, and then accordingly we are required to go ahead with the solution. So now let us go ahead with the coding part for the same. So here earlier I was trying with unordered map, but the thing is that in that context duplicates would be removed, so we can't go ahead with such a solution. So here basically, because we will be going ahead with the division part of the same, so that's why we are at the starting only we are just keeping a check that if k is equal to 0, and if nums of 1 and nums of 2 both of them are not equal, then in that context we will be directly returning -1, else we'll return 0. So this is the check which we are handling at the start, and then we are going ahead with traversing of our both of the arrays all together. Here we are keeping a check of the absolute of difference, and then we are checking that whosoever is greater, then accordingly whatever would be the difference we are pushing toward this account, and then means basically a vector which is storing all the counts, and then have adding up to the j, and then we are keeping a check that if that element is less than our nums2, then we are adding that up to the I, by subtracting in the other way around, means nums2 of L minus nums1 of L. Either we could have taken it like absolute of, if we would have been taking it like nums1 L, only and here also nums1 L. Then we would have just subtracted by directly having the absolute. And then here we are keeping a check that whatever difference is there, if it is not, if we do modulo with the k and it is not equal to 0, then we are making our flag equals to false. That simply indicates that how many number of time we will be adding up k or subtracting the k, we won't be able to make both of them equal. So in that context, we are making this check. And then after this particular has been done, then here only we will be checking that if whatever we have added into this j, where we were adding when a particular number is basically more than our second array, and here we were adding when a particular number is basically less than our second array. So accordingly, we are checking here that if both of them are not equal, or if a flag is also not also false, then we are required to return -1 because that simply indicates that how many number of operation we will be doing, both of arrays can't be equal. And then whatever um, what we say differences which we have stored in our vector, we will be directly dividing them by k. That simply indicates that this much number of times we will be doing that much operations, and in that we will be adding that to our result, and at the end we will be returning our result. So this is what is being required to do in this particular question. And now comes the part for the time complexity and the space complexity. So the time complexity is basically, here we can see that we are doing all operation is order of n time, and the space complexity here is we are taking this particular vector, and because of that the space complexity becomes order of n. So this was all for this particular question. If you have any doubt, you could comment that down with the timestamp of that particular portion. So yeah, this was all. Thank you.